Hello, welcome. My name is Andrew Chudd. I'm a senior software developer on the AWS Mobile Developer Experience team. And today I'm going to be talking about integrating video into mobile apps and websites. So I'm going to talk about the different types of applications that use video. I'm going to talk about some of the types of services that those applications require, some of the problems that they run into when trying to deliver video content to mobile devices. And I'm going to talk about some of the solutions that AWS has to offer to solve some of those problems. I'm going to talk about some example software architectures, and I'm going to launch one of those architectures live and integrate it with a mobile app and website. I'm going to talk about some of the new media services that launched this week at reInvent from the AWS Elemental team. And I'm going to talk about testing on AWS Device Farm. So at AWS, we're always really excited and proud to be part of our customers' great success stories, and mobile video apps are no exception to that. So we have a number of customers, a lot of different types of customers that use video as part of their product. For example, Abema TV is a leading media services company in Japan with their Fresh platform that has 1,400 channels of content, over 37,000 programs available for streaming, built on top of AWS. You have some companies that started in conventional television broadcasting, like PBS, that now stream, besides their 360-member television stations, they now stream content through websites and apps with pbs.org, pbskids.org, and PBS Video. And you have companies that, like DoApp, where their business is delivering customized video apps for other organizations. So DoApp produces 460 video apps for news organizations in 150 marketplaces in the US. All of these built on top of AWS services. So generally, the video apps and websites fall into a few categories. They're using video on demand streaming, where they've got some static content that is streamed to devices. They have broadcast, they're doing live streaming broadcast, for example, sports and news events. Or they're doing some kind of peer-to-peer communication, for example, chat apps or video teleconferencing, for example. And all of these types of apps run into some of the same problems, mainly around the fact that they're going to mobile devices. They are going over the air as far as their interface. They have an RF interface. And the problems with an RF interface are it's lossy. You end up with a lot of packet loss. You end up with retransmissions, which means higher latency in getting the data to the devices. And source content is generally very high resolution. They're very high bandwidth sort of formats. So your source content for your video is going to be 4K or it's going to be 1080p. And those files are very large. So you combine that with an unreliable over-the-air interface, and you run into some problems trying to deliver a consistent, smooth stream of video to your devices. You may also have issues, for example, if you're on Wi-Fi where you're on a network that's throttled. You might be at the airport, you might be at your hotel, and you might have your data rate throttled down to a pretty low level. So if you tried to play a high-resolution video stream in that environment, you'd end up sitting there with a loading spinner buffering your video, which would be a really bad experience. And add to that you have the normal conditions of having to go over network hops on the internet also. You also have to protect your content, which is true whether you're on a mobile device or not. So these are some of the problems that you run into. So some of the ways that you can deal with those problems with AWS solutions, one is to use a CDN. So if you use a content delivery network like Amazon CloudFront, you can deliver that cached content from edge servers that are physically close to your actual customers and their mobile devices. So you reduce the number of network hops that are going between the source of your content and the access point for your RF interface to your mobile devices. You reduce the number of hops there, reduce the latency there, and it improves the overall network conditions. So Amazon CloudFront has 107 points of presence worldwide. in 55 cities and 24 countries. So you can get those edge servers where you can cache your content, stream your content very close to your actual devices, no matter where your customers are. And again, streaming the original source content, which is going to be very high resolution, is not convenient over a lossy network. So you want to transcode that high resolution video down to formats that are lower bandwidth, they're lower quality formats that will transmit more easily over the air. And a great way to do that is to use an adaptive multi-bitrate format. So something like MPEG-Dash or HTTP live streaming that takes your video, converts it into multiple lower resolution formats in equal time slices, and the client on your mobile device can determine based on the network conditions how high of a resolution it can go and still keep a smooth stream of video for your mobile devices and your viewer. And if the network conditions improve, your client can step up to a higher resolution and have a better quality video. So here's examples of some of the different sort of encoding bit rates that you might use and flip between these depending on what the network conditions are. To protect your content, a common solution is to encrypt your data, to encrypt the actual files. So the segments of video that are delivered to the device are actually encrypted, and the player on the device contacts a license server to get a key to decrypt each segment of video. So it's a time-limited key that's only going to work for a certain amount of time. The user on the device will authenticate with whatever your identity provider is in your system. That gives them access to those keys to decrypt the data. And you can also use authorization to control access to specific URLs for specific content. So again, your user identifies themselves with an authentication service. That's coordinated to an authorization component, which will only vend the URLs to devices that are allowed to see that content. So this picture is a generalized service architecture as an example that you might use for streaming live video. And in this slide, we're using the mobile device as the source for the video also, which may not always be the case. If you're broadcasting a live sports event or news event, your source would be something else. And this is the architecture you'll see on a lot of mobile services in general. This isn't significantly different than other mobile services, where you have an identity service. So your users in your mobile app will sign in with the login and password through some identity provider. That's going to enable access control through an authorization service. You're going to have a service layer that's doing all your heavy lifting and business logic of your application. So for video, that's going to mean encoding your video, doing transcoding, possibly encrypting your video, packaging it. Maybe you have watermarks. Maybe you have ad injection into your video. That's all going to happen in your service layer. And the content's going to be vended out through your content delivery network to, again, provide the least number of network hops out on the internet and cached content whenever possible as close to the device. So this is a much more specific architecture that is really a video-on-demand architecture, but more in the context of a social networking kind of app. So again, your source is your mobile devices. And here, the mobile device authenticates with Amazon Cognito. So the user signs in to a Cognito user pool or some other identity provider that Amazon Cognito is going to federate. And it allows the device to directly use Amazon S3 simple storage service without a middle tier of software. So because of the fine-grained access control policies that are constructed over S3, you can use S3 directly from the mobile app. So in this architecture, users of the device will upload a video. In the S3 bucket, it will trigger a notification, which will invoke an AWS Lambda function. The Lambda function will read that file out of S3. It'll create a job in Elastic Transcoder Services, which is our video transcoding service. Elastic Transcoder will read the source file, convert it to those other media formats, for example, the HTTP live streaming format we talked about. It'll construct a playlist, which is a single manifest for that video with all the different video formats that it can ratchet up and down between. And it'll put that into the other S3 bucket and deliver it through the content delivery network, which is CloudFront. So we're going to build this architecture today. I'm going to launch it live. Everything I'm going to do is going to be directly out of a GitHub repository, so you can do the same thing in your own account. I'm going to talk about how these resources are deployed. So the resources you see on the client side, which are close to the devices, are all going to be configured by AWS Mobile Hub. AWS Mobile Hub is our mobile developer portal, which basically makes it very easy to configure a number of AWS services together, to work together to enable use cases that are convenient for mobile apps. So for this project, I'm going to use Cognito user pools for authentication. I'm going to use the user data storage feature in Mobile Hub for my video ingestion for the upload piece. And I'm going to use the hosting and streaming feature in Mobile Hub, which will enable the CloudFront distribution and my hosting S3 bucket to deliver the content. The other pieces on the right side of this diagram that I'm going to enable, I'm going to use the AWS CLI to do some automation. So I have a script that's going to create my Elastic Transcoder pipeline, and that's going to deploy my S3 notification trigger. So when we upload an MP4 file or a movie file to that user data file's S3 bucket, that'll trigger that notification and it'll run my Lambda function. I'm also going to deploy two CloudFormation templates, one which has my Lambda function in it, one which has some roles and permissions that are required for my transcoder pipeline and my Lambda function. And we're going to launch an Android app, which is going to be bootstrapped with the Mobile Hub project configuration, and we're going to launch a website, which is going to play video with the Mobile Hub configuration also. So if you want to follow along or run this in your own account, the GitHub project just went live this morning. It's called AWS Mobile Project Extensions, Simple Video Transcoding. And I'm going to go straight to that repository. So if you look through the repo, there's a large README file with detailed instructions, and you'll see the same architecture we just talked about. So I'm going to be going through some of the steps in that architecture. I already have my tools set up. I already have my credentials set up on my desktop. So I'm going to go ahead and download the repo. OK, so I have the repo downloaded into my downloads folder. And in there, I have a number of files. One is a create project script. So my create project script, this is just going to use the AWS CLI to create a mobile hub project. And it's going to use a specific snapshot ID. So you see the snapshot ID right here. That's going to enable a specific set of features that I've already enabled in another mobile hub project, and I exported it to a snapshot. So I'm going to create a project and give it a name. So this is using our public API for Mobile Hub to create a number of resources. And you'll see a lot of information output here. I'm going to scroll to the top of that. So I can see that it created a project with the name that I asked. It's got a unique project ID. My resources by default will be in the region that I specified. And it's giving me a link to the Mobile Hub console, which I'm going to go ahead and open. So here in the Mobile Hub console, I can see it's configured two client platforms for me, web and Android. I can get detailed integration instructions there on those. And it's turned on a number of features. So I can see the backend features that were turned on include user sign-in, user data storage, hosting, and streaming. So let's look at what it actually created for us. So every Mobile Hub project by default has an Amazon Cognito identity pool. And that identity pool will federate identities for your users across multiple identity providers. So they can sign in with social networks like Facebook and Google. They can sign in with Microsoft Active Directory using a SAML-based identity provider, or OpenID Connect, or any number of things. For this specific project, I'm using Cognito user pools as my identity provider. But Cognito can link those accounts together, give you one identity which you can use to control authorization policies for your mobile app users to talk to your AWS services in a secure way. And every Mobile Hub project has Amazon Pinpoint for analytics on by default, which will let you visualize how your users are using your app. You can get metrics data at scale from your users. So I turned on, in the snapshot, there was also the user sign-in feature. This is enabling my Cognito user pool. And this is creating an authenticated user role in identity access management that will have some policies, again, that control access for my users to my AWS services. And I'll go into detail on what those policies are. I turned on the user data storage feature, which gave me that S3 bucket we're going to use for ingesting video content from the devices. And there's some policies associated with that. We're going to look at those policies. And I turned on the hosting and streaming feature, which will let me host static website content. I'm going to host my website using that feature in Amazon S3 and CloudFront. And it will stream our video content from that S3 bucket through Amazon CloudFront also. So the next step I'm going to do, I'm going to use the AWS CLI, and I have a script set up to do that. So my little transcode setup script. And it's going to want a Mobile Hub project ID. I just created the demo project. I created one earlier today that I called Friday that I'm going to use because this project was created earlier, so I know my CloudFront distribution's already completely spun up and running on that one. Other than that, it's exactly the same command I just ran. It can take up to an hour for a CloudFront distribution to get started, so we didn't really have time for that. So now it's running a bunch of CLI commands, and it's going to deploy my resources on the back end. So let's go back and look at what it's doing. So the AWS CLI is going to read configuration from my Mobile Hub project. I gave it that Mobile Hub project ID. It's going to deploy 2 CloudFormation stacks. One has some identity and access management roles to provide permissions for Elastic Transcoder and to provide permissions for my AWS Lambda function. It's going to build and upload my Lambda artifact. So I have a simple Lambda function, which is in Node.js, and it's just going to zip that and upload that to Lambda and deploy that. And it's going to create my S3 notification trigger. So that's the thing that sees when I deploy a file to when I upload a file to my S3 bucket, if it matches the pattern I want, which in my case is a suffix of .mp4 or .mov, it's going to trigger the Lambda function. So the CLI is doing all of this. The 2 CloudFormation stacks that it's deploying, the first one is about roles and policies. So it's got 2 roles here. One is the Lambda execution role. This is the role that Lambda assumes when it's running. And it has the ability to read from my user files, S3 bucket, and write to Elastic Transcoder. I have another role, which is the role that Elastic Transcoder uses to read from my source S3 bucket and write to my hosting bucket. And the second CloudFormation stack actually deploys my Lambda. So this is it's got my Lambda build artifacts in an S3 bucket, and it also has the permission to invoke Lambda. So let's go to the console and take a quick look at those CloudFormation stacks. So I can see it's already completed creating the CloudFormation stack. And if I look at the roles stack, I've got my Lambda execution role, and I've got my transcoder pipeline role. And if I go to the other stack, I had an old one. My script will delete an old stack if you have it. It'll create a new one. The other stack has the Lambda function and permission in it. So it's deleting my old stack, and it'll create a new one in a second here. So I can see the CLI is running the commands. All the commands that my script runs, you could run yourself directly, and you can modify these. Every time it runs a command in the CLI, it's going to show a little output that shows execute, whatever the command is. You can see exactly what the script's doing. It's not hiding anything about what it's doing. So while that's deploying, I'm going to get our tool set up to deploy our website. So in this folder, there's a website folder. And I'm going to do an npm install. I'm going to do an npm install that's going to get some of my tools going for my website. Now, along with deploying my backend resources, those 2 CloudFormation stacks and everything I need, it also downloaded configuration files to bootstrap my Android app and to bootstrap my website. So let's take a quick look at those files. So in Android app, the file goes into the raw resources folder. So this file that was produced from the public API in Mobile Hub and downloaded through the CLI has all my identifiers that are required to bootstrap my mobile app. So my Android app is going to use these to know which Cognito identity pool to talk to and to know which S3 bucket to use and things like that. Similarly, my website has a similar file that was downloaded to bootstrap my website, and it has my constants in a nice JavaScript format that my website can ingest. So let's get the mobile app up and running. So I'm going to import the existing project. It's a Gradle project that's under my repo I downloaded. So it's under the Android folder, video demo, and build.gradle. So this is going to start building our Android app. While we're looking at that, I'm going to take another step to get our website up and running. So I'm going to build our website using Gulp. And I have a publish script for the website, which, just like my other script, it's going to ask for a Mobile Hub project ID. So I know which S3 bucket to deploy the website to. So I'm going to use that Friday project again. So this is going to copy the distribution that was built by Gulp in my website out into my S3 bucket. And it launches my Mobile Hub hosting and streaming page. I can get here in Mobile Hub from the hosting and streaming feature. And it gives me two launch buttons for the website. One is to launch the website running directly on S3, which is not cached, and one to launch it using my CloudFront distribution, which is cached content. So I'm going to launch it from S3. And I can see that my website is saying there's no content index available. So what I did in this software architecture is I needed a data store to store which videos are available to play. And what I did was I used S3 for that. So S3 is storing a file that just has a JSON file, which I'm calling a content index, which has the list of content IDs for the video files that are available to play. We haven't uploaded any video yet, so there's none available to play. So the website's sitting here on its polling loop trying to find stuff. So let's go back to the Android app, and let's start the Android app running, and then we'll go through the source code on the Android app. So we'll get our emulator up and running. And that'll take a minute while Gradle builds our app. So while that's going on, let's dig into the source code in the Android app a little bit. So to integrate with the Mobile Hub project, we have that file that we looked at earlier, that AWS configuration.json. It's in our raw resources file of our Android app. We also have some libraries that are in our build.gradle file, including AWS SDK libraries for Cognito and user pools and some other UI components that are going to help us out. So my Android app only has two activities. It has one that's going to sign in my users, and it has one that's going to deal with both recording video and playing video. So my authenticator activity is the one that's going to deal with sign-in. And in that activity, I'm just going to initialize the AWS Mobile SDK. I'm going to use the pre-built sign-in component. I'm using the defaults as far as all the visual elements for this sign-in component. You can customize everything on this. You can customize the image, background, fonts, colors, everything. But I'm using the defaults. And I'm telling it that when it's done signing in the user, it should run my main activity. My main activity is the one that really has my logic for recording video and playing back video. So let's see how our emulator is doing. OK, so we have our sign-in screen. The authenticator activity popped up, and I'm going to create a new account. So this is going to create an account in my Cognito user pool. I'm using a work mail account. So it's doing multi-factor authentication for my sign-up, so it's going to ask me for verification code. I'm going to use my work mail email there to get that, and it is 042044. Okay, so I'm signed up, and if I go back to my Mobile Hub console and I look at the resources page, I can get deep links to all my resources. So my Cognito user pool that I just used, I can deep link to that. I can look at my users and I can see, hey, I've got a new user and they've confirmed their verification code. And if I need to do things like reset their password or anything like that, I can do that. So at this point, my user should be signed in. Oh, I didn't sign in yet. Okay, so I'm signed in, and like my website, my mobile app is saying, hey, there's no content available yet. But it did give me this identity, which is my authenticated identity in Amazon Cognito. And this is really important for all mobile development on AWS, because this identity is the thing you're going to tie your data to for your user. And it's also the thing that controls authorization for requests to your services. So if I go to my resources in my Mobile Hub project, I can see, for example, that my S3 buckets were created. I've got my user files S3 bucket. And if I look at that bucket, it has 4 folders that were created for me. It has an uploads, public, protected, and private folder. These folders have authorization policies that Mobile Hub has crafted that give you behaviors that mobile apps need as far as users interacting with files. So the uploads folder is going to be a write-only case. So if maybe your users submit receipts or something, where they don't necessarily want to view what was uploaded, but they want write access. The public folder is like a graffiti wall. Anybody can read and write anything. The protected folder and private folders, under those you have a subfolder for each individual user where they can manage their own files. The private folder is read and write to just that individual user. The protected folder gives each user write access and gives other users read-only access to those files. So let's look at how that's actually implemented in my Mobile Hub. So Mobile Hub created some identity and access management roles for the mobile app. And it's got the auth and unauth role. When a user's not signed into your app, they're going to assume the unauth role, and that's the limited permissions they're going to have. When they are signed into your app, Cognito is going to give them limited time credentials, which their app can use to sign requests to make calls to AWS services. And the policies that they're going to get are going to be on this auth role. So on the auth role, I can see that Mobile Hub created a number of different policies. And specifically, the user files policy is the one I'm interested in. So I'm going to take a look at that policy. And what I can see is that in the policy, I have a number of actions that are allowed on my S3 bucket. There's a variable that's been put into the policy that crafts the permissions for this user. So the reason that a user can read and write to their own subfolder is because their identity is substituted in here when this policy is evaluated. So when the app makes a call to put a file, if the folder that you're in under the private parent folder is not that user's, they're not going to be able to read or write. And that's how the authorization policies are handled. So let's go back to our mobile app. Okay, so we've got our mobile app running, and I'm going to record a video. I'm going to get the Android permission prompts, which are normal, and then it's going to use the camera emulator in the Android emulator. And I'm going to just record some video. I'll give it a little time here. Okay, so it uploaded my video to my user files S3 bucket. And let's look at the Android code that did that. So in my Android main activity, I have an onCreate method that's going to register some button listeners to trigger recording the video. And I also, again, I'm using the Amazon mobile SDK, the AWS mobile SDK, and the identity manager, and I'm saying, get me the user ID, and this is an asynchronous operation. When that returns, I can see I get the ID from Cognito, and now I have that identity in the mobile app. And that's what's populating that text field you saw with the user's identity in the mobile app. Also in the activity, I have a timer running, basically. That's going to be my polling loop. So in my on-resume activity, I'm starting the timer. In my on-pause activity, I'm stopping the timer. And all the timer does is it tries to reload that content index file, which has the list of videos that are available. And by now, the video should be playing back on the device. So this is the post-transcoded video. It was uploaded to the S3 bucket. The Elastic Transcoder generated an HTTP live streaming format file. The mobile app found it and started playing it. So when it downloads that content index, and it's doing this on a polling loop, it's going to pull configuration out of that JSON configuration file I showed you that bootstrapped the Android app. That's how it knows where the S3 bucket is, where the CloudFront URL is. It creates a transfer utility from the mobile SDK, which is going to let me download that JSON file that's got the index of all the different video files that are available to play. And when it sees that it got a download and there's a new content available, it's going to call my setup video view method to play that content. And that's the method that's really interacting with the video view in the user interface. So it's just resetting it, and it's it's constructing a URL, and it's telling the video view to play that URL. So let's go back to our website real quick. Our website also picked it up in its polling loop. It found that there's video content to play. And in the website, not every browser has native support for HTTP live streaming. Safari does. The version of Chrome that I'm running does not. So I'm using a library called HLS.js, which is a JavaScript library that can parse the HLS content and flip between different bit rates from the playlist in that content. And I can see logs that are being output from my code on the right side, and I'll walk through the website code. But one of the things you'll see is that it's going to log events for what level of resolution the content is on. So if I go back to our code, we can see how that's happening. So first we have the trigger for the S3 function, or for the Lambda function from S3. The configuration for that is right here in my folder. My script created that. So it's looking for files uploaded with an MP4 index, or MP4 suffix, that are objects that were created, or an MOV if it's from an iOS device. And those are going to invoke my Lambda function. My Lambda function is going to use the AWS SDK, and it's going to interact with Elastic Transcoder and S3. So it's going to receive an event from S3, from that notification trigger, that it's going to get some information off of that. It's going to do a head request on the object to get some more metadata about that object in S3. Things like the user's IP address and the identity of the user that uploaded the file. I get that information. My Lambda function constructs an ID using timestamp in the user's identity, just so that I can have a nice ordered ID for my app. Likes to look at the latest video that was uploaded. And it's going to construct a request for Elastic Transcoder that specifies which video formats to transcode the video content into. So here I'm using 6 different formats in Elastic Transcoder that are going from low resolution to high resolution. And they all have the same segment duration. So my video is going to be split up into, I think I had 5-second intervals, and the player can step between those as it loads each segment, depending on what the network conditions are and if it's playing the video smoothly. So my Elastic Transcoder request has all 6 of these formats in a single playlist. It's an HLS, HTTP live streaming format playlist. And my Lambda function just calls Elastic Transcoder, says create the job with that request, and if that's successful, it then runs a function that I've created, which is going to take the ID that I allocated for that video, and it's going to drop it into that file in S3. And that's where the website and mobile app are picking it up. So let's look at the website code real quick. So the website's very, very simple. It has the HLS Jazz library I mentioned to decode the HTTP live streaming format if you're on a browser that doesn't have native support. It has the AWS mobile SDK. It has the bootstrapping configuration file that came from Mobile Hub. And as far as the elements on the web page, it's going to invoke my JavaScript method when the body of the page loads. It has a video element to play the video. And then it just has a couple other divs that I can put text into so you can tell what's going on with the script. My website code in JavaScript is very simple. It has a polling loop, just like my Android app, that's going to keep trying to load that content index file. And when it finds there's a new content index available, it's going to check to make sure it can read the video file. And when it does, it's going to load the video file. So here you can see in this method, it's setting up the HLS Jazz library. It's registering an event handler that says when the video is parsed, I want to start playing it. And I'm going to play it in that video element. And I have an event. I also registered for another event. There's a lot of events out of HLS Jazz. I registered an event to tell me when it switches between levels. And I have the HLS Jazz library attached to that video element. And when I have a new content ID, I tell it to load that as source. So if I go back to my website, that tiny video is only so interesting, so let's go to S3 and let's use a larger video file. So I have this is a 3-minute video file. I'm going to copy it from one S3 bucket to another. And it doesn't matter where my video came from as long as it lands in my project user files bucket, it's going to trigger that Lambda. So let's paste it in there. So my polling loop on my website is going to, as soon as the Lambda runs, it's going to find that there's another file that's transcoding, and it'll be able to play it when it's ready. So let's go to CloudWatch and take a look at what happened with the Lambda function. So we looked at the Lambda code. If you want to see what's going on with the Lambda function, I can go to CloudWatch logs. And I'm going to find the log for my Transcoder Job submitter, which is the thing I just ran. And here I can see that it received an event from S3. I can see that the event was triggered by my notification trigger that I showed you the JSON file that configures that. It has the bucket it came from. It has the path, which was under that private folder for that user. So if I look at my user files S3 bucket, I can see there's a private folder for that user, and there's the source content that they uploaded. So if I go back to let's go back to our website. So I can see the website now is playing a longer video of my cat Eva. So here you can see that it started playing the video on level 0, and it started with a size of 400 by 224. And the HLS Jazz library determined, hey, I've actually got really good network connectivity and really good bandwidth. I can step up the resolution of this. So it stepped it all the way up to level 4, which is 1024 by 576 format. So that's stepping through those adaptive bitrate formats, going from one to another. If my connection was really poor, it would step it back down to 1 or 0 and use that format. Let's go to the Elastic Transcoder job real quick. So if I go to the Elastic Transcoder pipeline, I can see what happened with make sure I'm in the right region. I can see what actually happened with my job. So in case my jobs fail, I can look here and see what happened. So I can see it was a 3-minute video. The source content was 1920 by 1080. And I can see it converted to each of those different output formats. So now one of the things I can do, because my website is hosted in the S3 bucket produced by Mobile Hub, I can actually run some tests on that website using AWS Device Farm for free. So AWS Device Farm is our pool of physical devices in the cloud. You can test your Android or iOS apps on physical devices in the cloud. You can run your own automation test suite, or you can use Explorer or Fuzz tests. And built into Mobile Hub, you have the ability to test websites, to do a performance test on them. So if I go into the Mobile Hub project, I go back. Here I can see under the web piece that there's a little run test button. If I click that, it's going to start scheduling my tests on physical devices to find out how the rendering of my website works. So I can see it's picked a pool of devices, which is going to include an iPad Air 2, iPhone 8, Google Pixel 2, some other devices. And that'll take a few minutes to run, but when it's done, it'll show me metrics on the time to first paint, and it'll show me screenshots on all the devices so I can see how my website renders. So you may have heard of some of the media services that launched this week from the AWS Elemental team. Now, everything I did in this presentation was done with Elastic Transcoder, which is our legacy video transcoding service. The equivalent of that in the AWS Elemental service that just launched is Media Convert. It's this middle one. It does exactly the same thing as Elastic Transcoder. It's just a new version of that service. Some of the other services that launched, Media Tailor does ad injection. So if you're trying to monetize your video streams, you can inject ads. Media Live does live transcoding. So you can whatever your source content is, you feed that stream in live. They will transcode on the fly to formats that can be streamed in the downlink direction. And they have a storage service, and they have a package service which can deal with encrypting your content, putting watermarks on your content, things like that. So definitely check out those services. Besides the services that AWS manages ourselves, we have a number of great partner solutions that are available in the AWS marketplace. You can check out some of those. And if you'd like to learn more about mobile app development on AWS, there's a number of sessions that you'll be able to find the videos on YouTube afterwards. You'll be able to find the video for this one also. You can, of course, use the GitHub project, which I just went through. Everything I went through as far as the mobile app, website, the scripts that did everything, it's all in that GitHub project. It's AWS Mobile Simple Video Transcoding, is the GitHub project. And the HLS Jazz library is an open source library that I used in the project. We have the AWS Mobile Development Forum, so please contact us. Let us know what you think. If you have questions, if there's features you want. We also have a feedback link on the bottom of the Mobile Hub console. 90% of our product roadmap comes directly from customer requests. So if there's a feature you want to see in AWS Mobile Hub, there's a feature you want to see in the mobile SDKs, let us know, and we'll work to get it into our product roadmap. So I'd like to thank you for your time today. Please remember to fill out your surveys. And I hope everybody had a great experience at reInvent this year. And I hope we'll see you all again next year.